Dale Brown.
And you can see just now it's a big outside garden. There's a big water testing site. And this is a great using for soil farming. Sometimes you want to have the soil, you can see the water. All that to be here.
How much water is the trees? Yeah, and like if you can extrapolate what type of runoff would it mitigate? And then thinking
well, this is not my expertise. Yes, this is a smart manufacturing lab. So they took that. They took the space from civil engineering and they built up different labs.
Yes, yeah, you can.
Yes, everyone. Yes. So this building is a part of civil engineering laboratory, and we are going to visit the civil engineering living lab for water technologies. So you can see in this laboratory there are different kinds of like R&D constructions and R&D technologies, and we can see the different plants, the green wall there, and also we have some rain gardens. So behind you, you can see here there are rain gardens. Under these leaves, they are soil, they are sand. So we just using the sand to treat the stormwater. So they are designed by the Monash University ourselves. So we designed this technology and we apply the technology in the campus. So this lab is designed in 2016 and we use that in 2017. So we can go inside and see different kinds of technologies.
มันซ่อนไว้จริงๆเนาะมันซ่อนไว้จริงๆพวกนี้ตื่น
Oh, Monday. Yes, so previously in this building there are different labs. You can see these two labs, but now they are taken by other projects. So we do have the access, but it's not good for us to get in. That lab is used for the microbiology stuff. So they are using the DNA RNA extraction and then analyze the sequencing of the DNA of the RNA, mainly for some viruses and bacteria in the stormwater. And these labs previously in the COVID period, we still doing a lot of like sampling from the sewage. So doing the sewage surveillance. So we understand what kind of virus, especially for COVID, what kind of COVID is in the sewage, in the wastewater. So we're using this lab, and you can see here from the window, there are a lot of like the big freezer. They are 80 degree freezer. So we use that freezer to store the samples from the wastewater. So these samples contains the SARS-CoV-2. So we use this lab to understand what sequencing in the SARS-CoV-2 and how many sites we can detect the SARS-CoV-2 at the early stage of COVID period in Melbourne. So we have very small cases. So we know which suburb has a COVID, give us an early warning. Because if before the people has a symptom of the COVID, and there are like the wastewater can contain some COVID. For example, this suburb, if we use these samplers to detect the COVID, but there is no people have the symptom, we know in this suburb has the COVID cases, so we can do more protections for different suburbs. So this lab is mainly doing a lot of like sequencing analysis, DNA and RNA extraction, but yeah, sometimes it's a little bit messy and dangerous, so we don't get into this lab. So let's go upstairs to the greenhouse to show some like R&D design and green technologies. Come in. So this is the environmental greenhouse. So we use this room or this space to build some prototypes about the R&D design, and we can feed and then grow up a lot of plants because it can receive the sunshine and it has very good ventilation. All the plants can under the weather, the exact same weather as outside, but no rainfall. So to solve this rainfall problem, so we want to get the plants irrigated by the rainwater. So you can see outside there are two big tanks. So outside the two big tanks are collecting all the stormwater from the weather, and then we use this pipe to irrigate the plants. So previously there are a lot of projects about what kind of plants can be used for stormwater treatment. So the full of the lab is with a lot of plants. And now we finished the project, so we have already cleaned up. And these two boxes, so we can treat it as a planter box. So previously they are small wetlands. So the wetland is used for like filling in the water, and then like what Dale explained yesterday, we use a real-time control technology to see what kind of material, what kind of pollutants can be removed by this wetland. And then after this project finished, Jianbin designed this like a waiting planter prototype. So we can see here is like two pipes joined together, and on this part you can come closer. And this is yeah, you can also see that. So this area is a small wetland, and at that area is a waiting planter. So actually, we can open this one. You can see. So here is like bell chart. So stormwater or grey water. Actually, this is already applied in Laos, in Lampubang, to mainly treat the grey water from the kitchen. So water can get into this small island from this inlet, and then keep flowing to the outlet, and then flowing down to the waiting planter. And in this island, you can see we use a coral mat to cover it, and the inside it's not soil, it's a clay ball. See, this is a clay ball, and we just use this clay ball to hold these plants, and then to make sure they are not floating up, and the plants can grow up very quickly. So we make these plants, we grow these plants, I think in December or November last year, and at that time it's like this big or even a little bit smaller than this. But when we plant it in, we damage a little bit of the roots, so they have regrow up. You can see these yellow ones, they are the old plants, and they are dying off. And during the summer, a lot of new things, new leaves grow up. And we can also see, see here, we lift up the outlet. This is still a lot of water inside. This is wetland, and we can see the water level is here. And why we use this level up? So we need to make sure we have enough water inside, and we can also change a little bit of the outlet, like the height. So if we move it a little bit down, the water level will lower. And if we lift it, like move up, the water level will be higher. And the treated water will flow downstream to this waiting planter. So our idea is, first of all, this is a subsurface wetland. It can treat the grey water, and then after the treatment, the water can flow down. And in this area is soil, and the soil we can use that to plant different kinds of like the flowers, or I can see in Labuan they plant some vegetables. So for the household, they can treat the grey water, and also they can use that to grow up some plants. They can sell them to the hotel. For example, the flowers they can sell to the hotel, or they can plant some vegetables for themselves to use. Yes. So and also we have the 100% completed that, but we can change a little bit to change the that outlet. We can change the level of the outlet to make sure we can change the water level inside of the wicking planter. Now sometimes it's a little bit wet inside. So in the summer, we may make it more water in the wicking planter, but in the winter time, we may change it to a low water level to make sure the soil is dry enough for the plants to grow up. Yes, and also Jianbin brings some like chairs and small table from his home. So in the household, so when we plant this, we can also use some entertainment like furniture to make sure people can hang out beside them. Yes, so we still have some plants left, and we may plant something in to make sure it looks better. Because now sometimes it looks like the plant looks low, and this one is on. But we have the landscape architecture for us to design what kind of plant we can plant in. So the first thing is this wall is it's easy to guide, and it's light, so we can reduce the weight. And the second thing, we can hold the plant in, it doesn't move, and also clay ball has a lot of gaps inside. It can absorb different kinds of pollutants, so it's better for the water treatment. Yeah. No problem. No, this is specifically designed for the household scale. So in the river scale, we don't use clay bar. We just use the soil and plant the plants in the soil. So just to make sure, I think Miao can explain more today. Just to make sure the water can flow through the wetland to do the water treatment. And we have some new technologies like the green technology already designed downstairs. And you can see outside we do have some sensor technologies I can show you later in another room. And these are the weather stations. For example, we use the local weather station to guide the wind speed and also the moisture PM 2.5 and PM 10 to get all the pollutant information from the air. And we have already applied different kinds of like sensor technology in logs. So I can show you later downstairs. Any questions? No? Okay, let's go downstairs. So the oil can be, so first there is an oil trap. So they will go through, I didn't show that because it's really hard to show, but in laws, the grease and the oil will get into the oil trap. So the water will be filtered by the oil trap, and the filtered water can get in through the so this is we have a pre-treated like device to treat the water. With the animal error here. So I just show you the first prototype we built up upstairs, which is a combination of the subsurface wetland and a wicking planter. Why we call it wicking planter? Because we use this kind of wicking fabric to put it underneath to make sure water can absorb. And I'm going to show you the second prototype I'm building up. So this is a green wall. So the green wall, the idea is we can use these pipes. So this is not the customized design stuff. This is just the PVC pipes. So we use the PVC pipes to build up a frame which can fit different kinds of plants. So for example, we drill different holes. We drill a lot of holes on the PVC pipe to make sure water can flow inside. And then we just glue them together and like a wall, like horizontally. And then we can fit different kinds of plants like this. So the first thing is we buy a small like planter pot, or we use like in Thailand people like to drink bubble tea. So this is just a bubble tea cup. So after we drink the bubble tea, we can use the cup and reuse the cup for recycling and plant some plants. So after we glue all of them together like a wall, we can just use this wicking fabric to wrap it, and then just fit inside like this. So, and then because the plants they will grow up, and then it will getting into a green wall. So you can see here, we do have about 120 these pipes, and the next thing I need to drill different like a lot of holes on that. So we can pre-buy some like the pre-drilled pipes to glue them together, but because of the budget or because of the supplier problem, I have to drill holes on that by myself. But in the future, it takes time. So I do a brief calculation. I need to drill about 8,000 holes for all of these pipes. It takes about a whole week. But in the future, we do have a Chinese supplier, and they can pre-drill the holes on these pipes, and we can build them up. Because for one prototype, the amount I need to buy is too small, so they don't want to treat me as a good customer. So I have to drill it by myself. And in the future, what we are going to do is like this frame is used for glue them together, and then make sure they are like vertically aligned with each other. So we can build up a big frame with wheels, like we just saw it upstairs. And there are about 120 like a pipe. How to say, plant holders, let's say the plant holders. So we can, after we drink the bubble tea or something, we can plant some plants in and just plug it in. So this is a big like green wall. So we can even use different kinds of plants, for example, different colors of the flowers to shape it as a big picture, which has a different kind of functions to reduce the heat island problem, to make sure it looks good, and also to cooling down the temperature, and this can be applied for Thailand as well. This is specifically designed for Thailand in Bangkok. Yeah.
So it's irrigated through stormwater runoff?
Well, we do plan a big water tank under this holder, these pipes, which is like we can still using the big pipes to make like a tank. So there is a small pump. So Jianbin found a pump, we can step on that. So kids can play with that to pump the water up to the top.
Okay.
Yeah.
So there would be a tank at the bottom?
Yes, there will be a
And
tank
then
at the bottom.
it's pumped up to the top?
Yes, it can be pumped up.
Right.
It can either by, if some people want to use electricity to pump it up, or
Yeah.
we just like kids can play with that. Just a step on that. It's a step on.
Yeah, it's a nature play.
Yeah.
The kids play with the water by stepping on the pumps, the pedal.
So these two kinds of design upstairs, the first thing is we can treat the grey water or the storm water anyway, and then we can use that to get some economy benefit. And this design is designed, it's not only for the stormwater treatment, not only for cooling down the environment, but also it can interact with the people around. So people can play with that, and also the bubble tea cup, we can recycle that for different kinds of environmental protection purposes. Yeah. Okay, any questions?
So the fabric is to keep moisture also.
The first thing is to keep moisture, and the second thing, when it absorbs the water, it can very easily, water can go through from different area. So it's not like this kind of clothes. So it can, after it absorb water, water can go through from the outside, getting into the inside. So it's not only need to irrigate the water to the soil, but if it absorbs water, it can get into the soil. Is that clear?
But then the fabric is outside the bubble tea cup.
Yes.
Do you do hole in the?
Yes,
to
inside
the
is a whole stuff.
bubble tea cup.
Yes, so we not only wrap up outside, but also inside. Yeah, so when it absorbs water, it can get inside, and the soil can absorb water as well.
So the bubble tea cup is just basically to keep the soil in place?
Yes.
And then you have holes in there?
No holes inside. It's just the water goes through from the clothes, the wicking clothes.
But are there holes in the bubble tea cup?
At the bottom, there
At the
are few.
bottom,
Yeah,
okay.
there are few holes. You can see here, it's like this. So we can drill some holes like this, yeah, to make sure the water can,
Oh, okay, so
yeah,
like that.
like some small
ก็
holes.
คือเหมือนการทำต้นไม้ทั่วไป
So then water is contained in this fabric and then it can go up.
Okay. So
Fabric is in the inside.
yes, so it's
inside and outside. Right?
yeah, it's like this. So it's not only outside,
It's a smart design.
it's inside.
So
So
it's
it
wrap
up from outside to inside. So water, if outside has water, it will go inside and then absorbed by the soil, and the plants can get water. Yeah, it's like this. So we need to cut it into the right size and make sure it wrap up for all the walls of the cup.
Other than geotextile,
Yes.
the woven or non-woven?
Sorry.
Woven or non-woven?
อาจจะ geotextile
What type of geotextile?
I'm not very professional in doing that, but yeah, we can easily get this kind of, we call it wicking fabric, but it's geotextile. So I'm not very familiar with different kind of specific stuff, but we just use that.
Okay.
Yeah.
It's the moisture absorbing geotextile, but we call it wicking cloth, wicking fabric. Yeah. Because the woolen one you talk about it just filter the soil. It doesn't retain moisture. You can touch this. It's like a sponge. Like sponge. It's absorb water and then pass it through. Yeah.
ฉับน้
Touch it.
ต้องนอนดูเป็น
Then you know what I'm talking about.
ำต้องเป็นมันเป็นต้องเปิดเหมือนที่เราถ่ายกันผมไม่ต้องการให้น้ำผ่านตกไม่ให้ดินผ่าน
Yes. You know.
สีอันนี้โดยปกติสีขาวจะเป็นนอนวูฟเว่นถ้าเป็นสีดำอะสีดำจะเป็นวูฟเว่นถ้านอนวูฟเว่นคือถักทอแบบสุ่มแล้วคือ
Once we drill on the hole, we'll send it into the wall
ดินที่มันอุ้มน้ำเนี่ย
horizontally.
มันจะอนุญาตให้น้ำผ่านได้อย่างเดียวเพราะว่าดินเนี่ยมันจะติดเส้นใยทำไม่ได้
And it is and it's double sided. The wall is double
ว่าหน้า
sided.
ไม่ผ่านถ้าเป็น
You can put a plant here,
ถ้า
also
เป็น
plant
สี
here.
ดำนะส่วนใหญ่มัน
So we put a coaster
แล้ว
on
มัน
the roll.
มันเป็น
You roll the
มันจะมีรูอย่างเงี้ย
according to
ดิ
the
น
sun.
ดินน้ำก็จะออกไปได้ด้วยกัน
Because during the day, the light is coming from the south. You're facing the south, and when the sun moving to the west, you rotate the wall to block the western sun, and then create a patio, create a space.
มันก็มีความเป็นเหมือนแบบว่า
It's like if this is the sun coming this way, right? If this is the house, so it block the sun, get cooling. When the sun moving to the west, you rotate this. So then this white shading, and this is also have plants. So the plants are double-sided, right? It's great. So it's not one-sided green wall, it's double-sided green wall. And this side you can set up a table, coffee table, chairs, a play area. And then we have a pump, a paddle pump. It's for kids to play. You press it and the water come out like a waterfall coming through. As you play waterfall, it also irrigate the plants. It's doing the two things at the same time. Yeah.
So should I place it on my living room?
Yes. If you have like a Thai barbecue, you set it up, block the western sun, you create this nice shade, look at the plants, and set up this Thai barbecue. Alright.
That is that restricting more. When you plant
It's horizontal. It's horizontal. Like a wall. So on the top one, you pump the water coming from the top, cascading.
But if you write it like a horizontal,
Yeah.
It means that
Yeah.
your plant is like this.
Yeah,
So the plant grow like this.
yeah, it can turn.
Oh,
Because
okay.
its growth is against gravity.
Okay. Okay.
Yeah.
Okay.
Yeah.
Understand.
Yeah.
เหมือนบ้านเรา
And you see, so in 2 months,
the microbiology stuff. So let's say that they all belong to the environmental monitoring. So we are doing a lot of environmental monitoring and we want to change the way for environmental monitoring. So first of all, previously, originally, we do the environmental monitoring use different kind of sensors. You know the sensors we can take. First thing is the sensors. We can monitor some physical parameters about not heavy metal, the water level, like the turbidity, different kind of physical parameters. And also, if we want to understand the pollutants level, we need to take the water sample and then do the laboratory test. But first of all, when we install the sensors, we probably need to have this kind of data logger. So for the environmental monitoring, the two stuff is essential. The first thing is a data logger, and the second thing is the sensor itself. So previously we used this data logger. This data logger works about $2,000 US dollars, and it's very expensive and it's very big. We need to get this kind of battery to power it because outside in the field we don't have the electrical supply, and then we need to find a cabinet, maybe this big cabinet, to make sure no one steal that, and to make sure it's not under the rainfall event. So we use a cabinet and then place all of these sensors, loggers, and also batteries inside, which is very big, very expensive, and very labor costly. And after that, we found we need to change a way to do the environmental monitoring. So we start to develop the low-cost sensors. So and the data logger. So this is a data logger we developed to compare with this. This is a much more smaller, and it can do a lot of more functions than this. So we use this kind of data logger to make sure we can connect to different kinds of the sensors and collect the data. And we can use different modules on the data logger to upload the data on the website. So for this one, we need to have a lot of plug-in, for example, like this, to plug it in and make sure the data can be stored in the SD card or uploaded online. But by using this, it's very cheap and small and very convenient. So this one is $2,000 and this one is $150. So it's very cheap, and it can get all the functions it can do, and it is smaller. So how we can place that? We don't need a big cabinet. We just need this kind of small logger box. For example, we can place it in the small logger box, and we do not use this big battery. We just use a small battery. So after we using that, we know we don't need a big cabinet. We just need this kind of thing. So we can combine all of the technologies and then put all the things in this small data logger. And for example, if we want to take water samples from a river, we can just use a steel bar to punch it into the river bed and then slide it in. So, and then after we design all of this, like the data logger, and we design different kind of sensors. For example, this is a turbidity sensor. Previously, the turbidity sensor is big, like this big, half of like 1/3 of the PVC pipe. And now we just use a small sensor. And this is a turbidity sensor. This is a depth, EC, and a temperature sensor. So it's a multi-function sensor. We can know the water level, we know the electrical conductivity, and we know the temperature of the water. So by these two things, we almost know all the physical parameters which is related to the environmental monitoring. And after that, we found, okay, it's portable and small, easy to installation, and then we need to take the water sample from the environment. And previously, I don't know if you see the big waters like a auto sampler. It's roughly like a cardboard. and it's very heavy and hard to install. We still need to install a big cabinet, and then we design a small, like a small auto sampler, which is like this. Which is like this. So this is very small. So if I take it out, we can just use 2 small batteries to power it. And it has different functions. It has like a remote control, remote communication functions, and we just plug it in and use glue to glue it on. Or we just need to like screw it out. So, and then we use this one to make sure the related program can just upload it to this this chip, and it can take the water sample stored in the pipe. So in the past few years, I used this set of the devices to take about hundreds of samples from all the rivers, not all the rivers, about 15 rivers from Melbourne, around Melbourne, and do the water analysis and the water sampling. So in my PhD, it's mainly using these low-cost sensors to understand what kind of pollutant processes and what kind of the non-traditional pollutant sources in the Melbourne. And also, we do have some like devices, like this is a camera. So this is a camera, we can have that using like 3 LEDs. So we use a camera and install the camera in the stormwater pit. So we take the water, take the pictures and upload the pictures online, so we can know the real-time data in the stormwater pit. So this, even though it is completely dark, so we use the LEDs to make sure we can see what's exactly inside. So what kind of, for example, the illicit discharges. So what kind of pollutants getting into the stormwater pipes. And also, this one is a radar sensor. So we designed this because sometimes if we want to understand the water level, and we need to make sure the water is in the sensor is in the water. Sometimes it needs maintenance. But this one we can just leave it somewhere on maybe on the river or on the pipe, and then it can send the radar signal to the water surface and then understand how much water from here to the water surface, and then we know the water level. So we don't need to do the maintenance because it's not in the water. As long as no one steals that, so it's just a changing battery. So after the battery died, we can just change the battery and it start to work again. So these kind of sensor technologies help us to understand the environmental problem and help us to understand which area has more pollutant and which area has more flooding. So we know what kind of strategy we want to use. And because all of the data can be uploaded online, so we know the real-time data. So we can just go to this is IoT. So we can just go to the website to check the status of this suburb, this river, and that lake, so we understand anything. And the last thing I want to introduce is this one. So as I said previously, this is a small we call it a passive sampler. So during COVID period, we use about 20,000 passive sampler around the world, and about 15,000 passive sampler in Melbourne. So we just use, because this is a rope, we just tie it somewhere and then leave it in the sewage network. Open the pit, tie it somewhere, leave it in the sewage, and after 24 hours or after maybe whatever, like maybe 2 days or 3 days, you can just take it out. And there are some like membranes inside. It can absorb different kinds of virus. So we know what kind of virus in the wastewater. So we can understand which part has like the virus, which part has this kind of disease, which part has that kind of disease. And even we can use this kind of thing for the drug detection. So a lot of things we have already done. And yes, so we changed the way for environmental monitoring from very complicated way to a very simple way. So in the future, when we do the R&D design, we want to know exactly what kind of pollutant will have been removed and how they work. So we can use these simple, low-cost, innovative technologies to deliver our environmental monitoring purposes. Yes, that is our lab. Any questions?
We do need to go back, but just really quickly, we can send you more information on the environmental monitoring on the sense.